Okay, so for this one, remember the three things you're going to do. You're going to rewrite, separate, and simplify each factor. Well, I guess you could say simplify each term. It's a little more accurate. Okay, so if we rewrite it, 5 over 6 times the square root. Remember, 45 is 9 times 5, so we make that the square root of 9 times 5 times x to the 4th. And I'll show you a little trick for that, x to the 4th. Plus 2 times the square root. Remember, 20 is 4 times 5, so we make that 4 times 5 times x to the 4th. Okay, so we rewrote them. Now we separate. So 5 over 6 times square root of 9 times square root of 5 times square root of x to the 4th. Plus 2 times square root of 4 times square root of 5 times the square root of x to the 4th. Okay, so a quick note about the x to the 4th, and we'll apply that immediately after. So if you remember, we have the nth root of x to the nth power. The n's cancel out, and you're left with just x. X to the 4th, we can actually make that x squared squared. So x to the 4th can equal x squared squared. Okay, so that means if we have the square root of x to the 4th, we actually have the square root of x squared. Oh, make that a little bit bigger. The square root of x squared squared. Okay, so remember, when there's nothing there, you automatically assume it's a 2. So those two would cancel out. So you're left with just x squared. Okay, so this can become 5 over 6 times square root of 9, which is 3, times square root of 5. You can't simplify that one, so that just stays square root of 5, times square root of 4, which we just worked out, to equal square root of 2. I mean, x squared, sorry about that. Plus 2 times square root of 4, we know that's 2, times square root of 5, can't simplify that one, so that just stays square root of 5, times square root of x to the 4th, which we know is x squared. Okay, so now we have 5 over 6 times 3. We can make that 5 over 6 times 3 over 1, which will be 15 over 6. And we'll simplify that in the next step. Square root of 5, x squared, plus 4, square root of 5, x squared. Okay. Actually, you can put the x squared next to that one if you wanted to. Doesn't really matter the order. Okay. But we do know, and let's go ahead and simplify it before we move to the next step. If we divide both of those by 3, we end up with 5 over 2, and I'll put the x squared over here. Let's kind of shuffle them around a little bit. You can do that with multiplication. Plus 4x squared square root of 5. Okay, so you have x squared square root of 5 and x squared square root of 5. So you can just combine those two. So 5 over 2, x squared square root of 5 plus 4, x squared square root of 5. We might as well go ahead and add our 5 over 2 plus 4 separately. Okay, remember that's going to equal 5 over 2 plus 8 over 2, which is 11 over 2. So if we add these two together, we'll get 11 over 2 x squared square root of 5.
How does 8 plus 5 equal 11?
13. Thank you. Going too fast. All right. Any questions on this one? All right. Okay, so now, oh, yes.
So, when I reduced the fraction, I got 2.5, and then I made it 6.5 x squared.
Oh, yeah, that's the same thing.
Good.
Yeah. All right. We'll still leave that up for a few more seconds. All right. Okay. Okay, so we're going to go back to multiplying radical expressions. But these are a little more complicated. Okay, so let's say if you have, I think of a good one, x squared times x plus 2. Okay, so you already know you just use the distributive property, which is just x squared times x plus x squared times 2, which gives you x to the third plus 2x squared. Okay, so we do the exact same thing when we're stuck with a radical expression we want to simplify. Okay, so if you want to multiply and simplify, let's say, where is it? Say square root of 3 times square root of 5 minus square root of 8. Okay, so we have our square root of 3 times square root of 5 minus square root of 8. We just go ahead and distribute that to both terms. Okay, so that would equal square root of 3, shorten that up a little bit, times square root of 5 minus square root of 3 times square root of 8. Okay, but remember, whenever you have them multiplied, You can combine them the same way you can separate them. So since square root of a times square root of b equals square root of a times b, we can just make this square root of 3 times 5 minus square root of 3 times 8. Okay, so here we have square root of 15 minus the square root of 24. Okay, where you're like 95% done. Okay, because you can't factor this 15 down and get a square root, but you can factor the 24 down. Okay, so you know that 24 can equal 4 times 6. Okay, so you end up with square root of 15 minus square root of 4 times square root of 6, but we're just going to go ahead and separate it. Okay. Square root of 4 is 2, so that gives us square root of 15 minus 2 square root of 6. All right, so any questions on that one? All right. Leave that up for a few seconds. Oh, looks like everyone's done. Okay, so let's say, for example, for this one, if we wanted to multiply and simplify, square root of 3x minus square root of 2y times square root of 3x plus square root of 2y. Just good old-fashioned FOIL method. Okay, so for our first, you have square root of 3x times square root of 3x. And your outer, square root of 3x times square root of 2y. Your inner, square root of 3x times negative square root of 2y. And your last, negative square root of 2y times positive square root of 2y, which is negative square root of 2y times 2y. Okay, so the middle two cancel each other out. They're just opposites. Okay, so here you actually get, once you combine those two, square root of 3x times 3x, which is square root of 3x squared, minus 2y times 2y will give you the square root of 2y squared. Let me write it down instead of skipping that step. I'll just go ahead and write it out. Square root of 3y times 3y. 2y times 2y, okay, which gives you square root of 3x. Sorry about that. Square root of 3x squared minus the square root of 2y squared. Okay, and remember, whenever you have a square root and nothing's there, you assume that that's a 2. Okay, which means your exponent and your index cancel out. Okay, when they cancel out, you're just left with 3x minus 2y. All right. Any questions on that one? Okay, leave that up. Okay. Okay, so let's say if we wanted to multiply and simplify. Say -3 times the cube root of 10 times y to the third, and that raised to the third power. Okay. Now you don't have to write it 3 separate times. All you have to do is remember the power of a product rule. A times b to the n is going to equal a to the n times b to the power of n. Okay. So applying that here, you have -3 times the cube root 10y to the third, and all that raised to the third power is going to equal -3 to the third times the cube root of 10y to the third Okay, so you just raise both factors to the third power. Okay, so we know -3 times -3 times -3 is -27. Okay, so we also know here that whenever you have an index and a square and a exponent that are the same, they're going to cancel out. So these two actually cancel each other out. So that's going to be times 10y to the third. Okay, so you end up with -270 y to the third. All right. Any questions on that one? Okay. Okay, so let's say if we have multiply and simplify. There. Say 2 times the cube root of 7x squared, and that raised to the third power. Okay, and I'll let you start on that one. right, so for this one, so we have 2 times the cube root 7x squared to the third power. That's just going to be 2 to the third times the cube root of 7x squared to the third. Okay, as you know, 2 to the third is just 8. Those two cancel each other out. So it's times 7x squared. So you end up with 56x squared. Okay. Okay, any questions on that one? Okay. Okay, so now we're going to simplify radical expressions with division. Okay, in that case, you just have to rationalize the denominator. Okay, so rationalizing the denominator is just another way of saying really you're just going to get rid of any root symbols in the denominator or any radical symbols. Okay, now to do that, you really just have to remember say square root of 2 times square root of 2 equals 4. Or square root of 5 times square root of 5 is just going to equal square root of 5 squared, or square root of 25, which is just 5. Or if you have square root of 3y times square root of 3y. Remember, that's just going to be the square root, once you multiply those two together, square root of 3y squared, with a square root and the index cancels out, you end up with just 3y. Okay, so even if you have, let's say, cube root of x times the cube root of x times the cube root of x, that would actually equal the cube root, once you multiply all those together, of x to the third, where this cancels out and you end up with just x. So we're going to use that to get rid of the root symbols or radical signs in the denominator. Okay, so let's say, for example, we want to rationalize the denominator. Let's say for square root of 20 over 7. Make that over the entire thing. Okay. Now remember, that if you have, let's say, a over b to the nth power, that's just a to the n over b to the n. So remember, this is just 20 over 7 to the 1/2 power. So that means if you have the square root of 20 over 7, that's just going to equal 20 to the 1/2 power over 7 to the 1/2 power, or square root of 20 over square root of 7. So clean that up some. Okay, so now that you have square root of 20 over square root of 7, to rationalize the denominator, you want to get rid of that square root of 7. So you actually multiply both by square root of 7. Okay, so that actually gives you square root of 20 times square root of 7, which is square root of 20, I'll just write it out, times square root of 7 over square root of 7 times square root of 7. Okay. Which, once you get those, you can just put them all under one square root symbol. So square root of 140, I'll just go ahead and write it out. Square root of 20 times 7. Square root of 7 times square root of 7, we already know that's going to equal 7. That's what we were kind of showing up there, that when you get the square root of the same thing times itself, it's just going to cancel out the square roots. Okay, which gives us square root of 40, square root of 140 over 7. Okay, now we know that 140 is equal to 35 times 4. Move that up a little bit. We can make that square root of 140 square root 4 times 35 over 7. Okay, once we separate those, we have square root of 4 times square root of 35 over 7, which square root of 4 is 2, so we just make that 2 square root of 35 over 7. All right, so any questions on that one? That's getting ready to shut off. All right.